This is a tutorial on solving quadratics using square roots. The first thing we're going to talk about are the properties of square roots. If we have two numbers a and b, and they're both greater than 0, then if we have the square root of a times b, that's the same as the square root of a times the square root of b. So if we have the square root of 18, you can think of this as the square root of 2 times 9. And if we have the square root of 2 times 9, that's the same as the square root of 2 times the square root of 9. Well, we know what the square root of 9 is. That's just 3. But the square root of 2 is some irrational decimal, so we'll leave it as the square root of 2. So if we have 3 times the square root of 2, our answer then is just 3 root 2. Now again, if we have numbers a and b and they're both greater than 0, and we have the square root of a over b, well, that's the same as the square root of a divided by the square root of b. So if we have the square root of 9/4, this is the same as the square root of 9 over the square root of 4. Well, the square root of 9 is just 3, and the square root of 4 is 2. So the square root of 9/4 then is just 3/2. Next, we're going to talk about rationalizing denominators. Rationalizing denominators are just methods for getting rid of a square root that's in the denominator. So if we have the square root of 6 over the square root of 3, we can multiply this by the square root of 3 over the square root of 3. Remember, any number over the same number is just equal to 1. If we have 2 over 2, that's equal to 1. 3 over 3 is still equal to 1. So the fact that we're multiplying this fraction here by the square root of 3 over square root of 3, we're not changing its value because we're really multiplying it by 1. But if we do this and we rewrite it, we'll have the square root of 6 times the square root of 3 over the square root of 3 times the square root of 3. We can rewrite the square root of 6 times the square root of 3 as the square root of 6 times 3. And then the square root of 3 times the square root of 3 is just the square root of 3 squared. Well, the square root of 6 times 3 is the square root of 18. And the square root of 3 squared, well, if we square root and then square, we just lose the square root. So this would just be a 3 in the denominator. So now we've rationalized this and got our square root symbol out of the denominator. But we're not quite done because we can still simplify this. We can think of the square root of 18 as the square root of 9 times 2. And then that would be the square root of 9 times the square root of 2. Well, the square root of 9 is just 3. So we'd have 3 times the square root of 2, still over 3. Our 3's would cancel, and we'd be left with just the square root of 2. Let's look at our next example. We have 2 divided by 3 plus the square root of 5. Now, because we have 3 plus the square root of 5, this is going to be a little bit more difficult on getting rid of the square root symbol. We can't just multiply it by the square root of 5 because you would end up with 3 times the square root of 5 in the denominator. So to get rid of our root symbol in the denominator, we're going to use the identity of difference of two squares. Remember, if you have an a squared minus b squared, you can factor that into an a minus b times an a plus b. So what we're going to do is we're going to multiply this fraction by 3 minus the square root of 5 over 3 minus the square root of 5. Again, we're not changing the value of our fraction here because 3 minus the square root of 5 over the 3 minus the square root of 5 is just 1. So we're multiplying this by 1. But if we do that, we'll get 2 times 3 minus the square root of 5 over 3 plus square root of 5 times 3 minus square root of 5. Well, this denominator then looks just like our factored form of our difference of two squares. So this would simplify then into an a squared minus b squared, where 3 is our a and b is our square root of 5. So if we do that, this is 2 times 3 minus the square root of 5 over 3 squared minus the square root of 5 squared. Now if I square the 3, I get 9. And if I square the square root of 5, I just get 5. So this is 9 minus 5 in our denominator. And on the top, we still have our 2 times 3 minus the square root of 5. If I distribute this 2 inside, we'll get 6 minus 2 square roots of 5. And this is over 9 minus 5, or 4. Now lastly, we can take a 2 out of this. So what we get is 3 minus the square root of 5 over 2. And here we've rationalized our denominator. We got the root out of the denominator. And then we simplified, so this is 3 minus the square root of 5 over 2. So now that we know all the ways to use square roots, let's try using them to solve a quadratic equation. Here we have 10x squared plus 7 is equal to 47. What we're going to do first is get this x squared by itself on one side of the equal sign. So we'll subtract 7 from both sides, and we'll get 10x squared is equal to 40. Divide by 10 on both sides, and you'll get x squared is equal to 4. Now to get rid of this square, we're going to square root both sides. Now if you square root a square, that means you get x is equal to the plus or minus our square root of 4, which the square root of 4 is just 2, so we have x is equal plus or minus 2. And this would be our solution. Or you could write it as x is equal to 2 or negative 2. Remember, both of these work because if we plug in a negative for our square term, it goes positive. And again, if we plug in our positive, it stays positive. So our solutions then are x is equal to 2 or negative 2. Our next example is 5 times x minus 3 squared is equal to 40. Well, we're going to get this x minus 3 alone, so let's divide both sides by 5. And we'll get x minus 3 squared is equal to 8. Now again, we're going to square root both sides to get rid of this square term. Now if we have the square root of a square, we get x minus 3 is equal to plus or minus the square root of 8. So that means we have x minus 3 is equal to the square root of 8, and then we have x minus 3 is equal to the negative square root of 8. So we'll add 3 to both sides on both equations, and we get x is equal to 3 plus the square root of 8. Now we can simplify the square root of 8 as the square root of 4 times 2. And then that would be the same as the square root of 4 times the square root of 2. And the square root of 4 is just 2, so we have 2 root 2. So then x would be equal to 3 plus 2 square roots of 2. We have to deal with our other equation here. We're adding 3 to both sides. So we're going to get x is equal to 3 minus the square root of 8. And then if we go through the same simplification, we're going to get x is equal to 3 minus 2 square roots of 2. So our two solutions then for this quadratic would be 3 plus 2 square roots of 2 or 3 minus 2 square roots of 2. And that completes the tutorial on solving quadratics using square roots.